For as long as we've known about them, black holes have been seen as this ultimate cosmic dead end. You fall in, and that's it, game over. But what if that's completely wrong? There's this incredible paper from a researcher known only by their initials, KS, that flips the whole idea on its head. It suggests a wild escape route, one that could literally connect our universe to, well, somewhere else.
So yeah, let's just put the central question right out there. What if everything we thought we knew about black holes is just half the story? We see them as traps, as cosmic prisons. But this theory from KS.ASTRO asks us to imagine something totally different. What if they're not a trap at all, but a doorway?
Okay, so before we can really get into KS's radical idea, we've got to get on the same page about the standard picture. Let's do a quick refresher on what Einstein's physics tells us about these things we call black holes.
All right, so the classic way to picture this is to think of space-time like a giant, stretchy rubber sheet. A planet or a star makes a little dip in it. But a black hole? That's not a dip. That's like poking a hole clean through it. The gravity is so intense that once you cross that line, the event horizon, that's it. Every single path, every possible direction, only leads one way, down. You can't turn back, you can't stop. Not even light, the fastest thing there is, can get out.
And right at the very center of this whole mess is something called a singularity. Now this is where things get really weird. It's a point where all the matter is crushed down to, well, an infinitely small, infinitely dense point. And at that point, our physics just breaks. All our equations, Einstein's and the quantum ones, they just spit out nonsense. It's basically the universe putting up a giant sign that says, you don't have the right math for this yet.
So this breakdown in the laws of physics leads to a massive puzzle. You see, one of the most fundamental rules in the universe is that information can't be destroyed. Think about it. If you burn a book, the information is still there in the smoke, the ash, the heat. But what happens when that book falls into a black hole? If it just gets crushed into a singularity, where does the information go? It can't just vanish. That's the famous black hole information paradox, and it's a huge headache for physicists.
All right, to even start thinking about a solution, we have to introduce a pretty weird concept, the black hole's mirror image, its theoretical twin. To solve the problem of a cosmic entrance with no exit, maybe we need to think about a cosmic exit with no entrance.
And that brings us to the white hole. It's exactly what it sounds like, the complete opposite of a black hole. It's a region of space-time that you can't get into from the outside, but stuff can come pouring out of it. It's like a black hole movie played in reverse. The crazy thing is, Einstein's equations totally allow for them to exist, but we've never ever seen one.
So let's just lay it out side by side. Black holes pull stuff in, white holes push stuff out. One's an entrance only, the other's an exit only. One traps information, the other, theoretically, radiates it. And here's the kicker. We see black holes all over the place. White holes, they've been stuck in the hypothetical column. Or at least they were.
And this is where KS's hypothesis comes crashing in and gets really cool. The idea is that these two things, the black hole and the white hole, aren't separate objects at all. They're actually two ends of the very same thing, a kind of cosmic tunnel. So here's how it would work, step by step. Step 1, something falls into a black hole, crosses the event horizon, business as usual. But then, step 2, instead of getting squished into that singularity, the crazy intense gravity and space-time curvature actually tears a hole in reality. And that tear, step 3, creates a passage, a wormhole. And finally, step 4, all that matter and information that fell in comes blasting out of a white hole, somewhere else, maybe in a different galaxy or a whole other universe.
And here's the idea in KS's own words. The key phrase here is continuous structure. It's not a black hole and a white hole. It's one single object, a tunnel through space-time that just looks like a black hole from one side and a white hole from the other, an entrance and an exit.
Okay, I know what you're thinking. This sounds awesome, but it also sounds a lot like science fiction. And you're right. Based on the physics we have right now, it is. To make this idea work, you need a missing piece, a new kind of physics to describe what happens in these extreme situations.
Yeah, this is the big hurdle. Einstein's theory of general relativity, which works so well for everything else, described space-time as the smooth, continuous fabric. It can bend and warp, but it can't just tear. So how does this theory get around that? How do you turn a dead-end singularity into a tunnel?
Well, the answer, according to KS, lies in the holy grail of modern physics, quantum gravity. See, right now we have two rule books for the universe. We have general relativity for really big stuff like planets and galaxies, and we have quantum mechanics for really tiny stuff like atoms and particles. The problem is, they don't work together. Quantum gravity is the dream of a single, unified theory that could explain everything, especially the super tiny, super heavy conditions inside a black hole.
And this is absolutely central to K's whole idea. This theory isn't just compatible with quantum gravity, it depends on it. It says that once you factor in quantum effects, the singularity isn't an infinitely sharp, physics-breaking point anymore. Instead, quantum gravity smooths it out, preventing a total collapse and allowing space-time to form a tunnel to the other side. The singularity isn't a dead end, it's the beginning of the wormhole.
So, let's just imagine for a second. Let's say KS is right, and quantum gravity really does this. What would that actually mean? What are the implications if this is how the universe really works?
Oh, they are just mind-blowing. For starters, it neatly solves that big information paradox we talked about. The information isn't gone, it just gets rerouted through the wormhole. Boom, solved. Then it gives us a real, physical way for a multiverse to exist. Maybe every black hole in our universe is a doorway to another one. And finally, it takes wormholes, or Einstein-Rosen bridges, from being just a weird mathematical curiosity to something that could actually be real.
You know, what's really beautiful about a theory like this is how it connects the dots. It takes a huge problem from Einstein's general relativity, the singularity, and uses a solution from the world of quantum theory. In the process, it could completely change cosmology, our understanding of the universe as a whole. It's a bridge between the biggest ideas in physics.
And that really leaves us with one last big question to chew on. This whole idea from KS is for sure still just a theory, but it forces us to look up at the sky and see things differently. If black holes, the universe's darkest prisons, are actually secret doorways, it just makes you wonder, right? What other incredible cosmic secrets are hiding out there right in plain sight?